All right, today we're going to be looking at three different sections. Like I told you a while ago, we're going to jump around a little bit here and tried to cut down the last three chapters here. Well, there's four chapters, but the last three chapters we're going to look at into just the most important parts. And so today we're going to look at one thing from 10.3, one thing from 10.4, and part of 10.8. So the one thing that I want you to know from 10.3 is theorem 10.2. Theorem 10.2. It says in a circle, two minor arcs are congruent if and only if their corresponding chords are congruent. So just very basically, what it's saying is if you have a circle, you have two chords drawn in to the circle, say A, B, and C, D. It might not look like in my diagram, but if AB is congruent to segment CD, then the arc AB is equal to the arc CD, or they're congruent arcs. All right. So some examples. Should use the bigger diagram. There we go. If we have a circle and this segment is 13 and this segment is 13, those are two chords. And we know that the arc from here to here, call it AB, is 79 degrees. Then what would X have to be? Well, since AB and CD are congruent, they're congruent chords, then the arcs must be congruent as well. So X is 79. All right, same kind of idea, right? Two arcs or two chords in a circle, both 14. That means they're both congruent. And if we know the arc up here is X plus 17 and 4X plus 2, these two arcs must be congruent. So 4X plus 2 must be equal to X plus 17. And if we subtract X from both sides, we get 3X. If we subtract 2 from both sides, we get 15. So X would be 5. And here then, if we had, just kind of putting it the other way, 36 and 2x minus 12, and we knew that this arc and this arc are congruent to each other, then the two chords have to be congruent. So 2x minus 12 has to be equal to 36. 2x is 48, and x is 24. And one more for this section. We were given a circle like this. We have two chords drawn in that are congruent. That means the arcs that they hold must also be congruent. So since this is X, this must also be X. This one's a little bit different in that we have three arcs all around the circle that make up the whole circle. So these three arcs have to sum to something specific, and that specific thing is 360, the amount of degrees around a circle. So x plus 38 is 360, or 2x plus 38 is 360. Subtracting 38 from both sides, we get 2x is 322. And then divide both sides by 2, and x is 161. All right, and that is all that you need to know from section 3. From section 4, the one thing that we care about is theorem 10.6, which is the inscribed angle theorem. This says if an angle is inscribed in a circle, then the measure of the angle is half the measure of the intercepted arc. Intercepted arc. All right, so again, just kind of basically what this is saying, inscribed angle is an angle that the vertex is on the circle, right? So you might have angle 1 here and then arc AB. What this is saying is that the measure of angle 1 is 1/2 the measure of the arc AB. All right. So basically all of this section is going to be either multiplying or dividing by 2, depending if we're going for the angle or the arc. So if we have our circle, three and x, y, right? What is the measure of arc xy? Well, if the angle is half the arc, then the arc must be twice the angle. So we're taking 2 times 23, which is 46 degrees. And that's it. That's all that we're doing. But D, E, F. And what if we knew that the arc DF was 162 degrees? What is the measure of angle E? Well, E is an inscribed angle, so it must be 1/2 of 162, which is 81. The last 2 examples of this that we'll do are really the only way it gets any more difficult than that. If we know this is 120 and this is 140, might ask for the measure of angle R. Well, if this is 120 and this is 140, what is left for QR? The 120 plus 140 is 260. We need 360 around the circle, so QR is 100. And the measure of angle R is half of that, which is 50. measure of arc MP is what it's asking for here. So notice your first inclination is probably to find the measure of arc MN, which you will need to do. I guess I'm missing one piece of information here, which is that PN is a diameter. It goes through the center. Might not look like it, but it does, right? MN is 62. And so the measure of MP must be 180 minus 62 because a diameter cuts the circle in half, 2 parts of 180, and we're left with 118.